Today I am explaining about the TTL NAND gate with the open collector. So the circuit diagram of the TTL NAND gate with the open collector as shown figure. So details of the circuit, it contains three different transistor like Q1, Q2 and Q3. So and each one transistor contains the separate terminals like emitter, base, collector, and each transistor contains the separate resistor. Here the transistor Q1 contains the multiple emitters and both the multiple emitters terminals act as a input of the NAND gate. And the transistor Q3 contains the open collector, so it can be defined as nothing is connected at the collector of the output transistor, so it is known as the open collector, and this collector terminal is available as a IC pins. And now I am explaining actual operation of the above circuit. It contains two different cases, case 1 and case 2. Now I am explaining about the case 1. If A is equal to 0 or B is equal to 0 or A is equal to B is equal to 0, if either A or B are both at low, then base to emitter junction of Q1 is forward biased and its base to collector junction is reverse biased. So there is a current through R1 and the base to emitter junction of Q1 enter into the low input. There is no current into the base of Q2 and hence Q2 is in off mode. So the emitter of Q2 is at a ground potential and it keeping Q4 into the off mode. Therefore the output level will be high if an external load or resistor is connected between the output and VCC. VCC is the supply here. So today I am explaining about the and now I am explaining about the case 2. Here A is equal to B is equal to 1. If both the inputs are high, the base to emitter junction of Q2 is reverse biased and its base to collector junction is forward biased. So it permits the current through the R1 and the base to collector junction of Q1 is enter into the base of Q2. Therefore the transistor Q2 is turned on. Due to the Q2 is on, Q4 resistor also gets the sufficient base drive voltage from the supply VCC and it enter into the saturation mode. Therefore the output goes to low level. It means whenever in AND gate both the inputs are high, then output is high. And in AND gate when A is equal to 0 or B is equal to 0 or both are 0, then it gets the output is high level. Thank you. Here the transistor Q1 contains the two inputs, so they are the multi-emitter terminals. So these terminals act as input of the NAND gate, and at Q3 a transistor, nothing will be connected at the open collector. That means since nothing is connected at the collector of the output transistor, so it is known as the open collector output. So these terminals are available as IC switches, and now it contains two different operations like A is equal to 0 or B is equal to 0 or both A is equal to B is equal to 0. So whenever both the inputs are low or either A or B are low, then the base to emitter junction of Q1 is forward biased and base to collector junction is reverse biased. Therefore the current is enter into the R1 and that base to emitter junction of Q1 is enter into the low input. Therefore no current into the base of Q2 and hence Q2 is in off mode. So the emitter of Q2 is at ground potential and it keeping Q4 into off mode. Therefore the output level will be high if an external load is connected in between the output and VCC. Next case 2, if A is equal to B is equal to 1, both the inputs are high, the base to emitter junction of Q1 is reverse biased and its base to collector junction of junction is forward biased. Therefore this permits the current through R1 and the base to collector junction of Q1 enter into the base of Q2. Therefore the transistor Q2 is turned on. Whenever the transistor Q2 is on, then Q4 transistor gets the sufficient base driven voltage from the VCC and it is entered into the saturation mode. Therefore the output goes to low level. Thank you.